Hello, everyone. Today we are here to talk about the crossroad of security and observability in Kubernetes. I'm really thrilled to welcome Stan Lee, who is head of security architecture at PayPal. He has a lot of experience in the area of cybersecurity, and I'm really excited to chat with him and get his thoughts on how this whole thing of security and observability, how they play out in the world of Kubernetes.
Hi, Manish. Thank you very much for the invitation to be able to join you and the security team here. So super excited to have an opportunity to connect with everyone. Just by way of introduction, as you mentioned, I am the head of security architecture at PayPal. My team and I are really a technology-driven organization, and we're responsible for shaping the security strategies that enables PayPal to adopt its business and grow its business through risk management in a variety of companies. Early in my career, I spent time in very large telecoms, such as Lucent Technologies and Nokia Communications. In more recent years, I've moved on to products and services companies like Palo Alto Networks, Intuit, and now at PayPal. One of the things that I've always enjoyed is being able to work with incredible talents in our industry and always finding new ways of pushing the limits of technology. So I'm super excited to be here to talk with you today.
Yeah, it must be very exciting to be involved in a large corporation like PayPal, managing security. It's daunting and challenging as well. So really looking forward to getting your thoughts on security and cloud native applications. So tell me a little bit. What are your thoughts? You've been in the industry, you've seen a few cycles, and now we have cloud native applications, specifically Kubernetes. When somebody says to you security for Kubernetes cloud native applications, what are the top few things that come to mind? What do you think of? And it would be great to share that view with our users.
Yeah, I think the cloud architecture and what we're doing in public cloud these days are extremely challenging, and certainly something that's been changing for quite some time for us. We've seen the technology evolve over the last few years, and a lot of times when I look at the cloud technologies, one of the things that's top of mind for me is understanding from a technology standpoint, from a business standpoint, what is the real driver for a lot of these organizations to adopt cloud native technologies? And a lot of times I find myself to be in a position where we're talking about really about developer velocities and the pace of innovations that could potentially happen in the cloud. And what we as security professionals need to do is to keep that in mind and understand why we're doing it. How do we enable the scalability, elasticity, and then oftentimes it's really about how do we grow the business faster together, right? And this really creates a very different mentality, different mindset for a lot of us as we continue to work with our partners in the companies, whether you're on the product side, you're on the engineering side, whichever part of the company your role is involved in. And a lot of times that really means that we have to change the way that we operate as a secure organization. And we also need to look at the tools that we have in place and the infrastructures and technology we have in place, and how that needs to adapt to enable successful adoption of public cloud technologies and cloud technologies as a whole.
Yeah, so you mentioned a few very interesting things there. A couple of things. You said, successful adoption of cloud technologies, right? Which is why everyone wants to go to cloud. Well, behind that, if you will, successful adoption means leveraging all of the, pace of development. You covered that. You talked about elasticity, scale, ability to do things better. Now, in the backdrop of all of this, when you start to think about security, tools come to mind, right? In the traditional world, when we used to think about security, it's like, okay, I'm going to build everything and then I'm going to secure it. It's a little bit different here. So, if you can describe a little bit more about what are your thoughts on that, right? There's this whole paradigm shift left security. How do you think about it, and what needs to happen in a large organization that's transforming itself or trying to move towards the cloud?
Yeah, I had the fortunate benefit of being with a couple of organizations that had gone through that journey, and you and I have actually been able to go through that journey together in part of our earlier career together. Fundamentally, to your point, a lot of secure organizations have a tendency, or through historical context or other reasons, they're really looking at how do we enable the risk management towards the organization. But when it comes to developing technologies on cloud, because of the velocity, how fast things are moving, how we now actually change the way that we do technology development, software engineering, becomes very iterative approach to it. We're no longer, very rarely do we find the older style, the waterfall methodologies. So what that means is that a lot of security professionals need to be part of the development process. They need to get involved as early as product concepts and work through the design process with the product managers, the engineers, work with those folks to understand very early on what is it that we're trying to accomplish together, what are those outcomes we're building to. As we continue to work through that development process, we need to make sure that our tools are also embedded in the same way. So we're no longer able to go in and look at the code, look at the design after it's done. We have to be very much involved as part of the embedded process, and that's the whole concept behind the shift left methodologies. A lot of other organizations describe it as being SecDevOps, and in some cases DevSecOps, right? That's the terminologies that's being used quite often. But most importantly is be a partner with the engineering team, be a partner in the design process, be a partner in the build process. So as we're building these technologies together, we are part of that particular fabric that enables the development process, so that we are part of the step every single way. So the tools are also need to be embedded in the same way. So part of the tooling now, there's no longer a go scan, do a check, do a scan, and then look at whether or not that passes or not pass. A lot of times it's providing the right sets of information back to our customers, back to our partners as early as possible, so that they could start to make those security decisions early on in the process as part of the actual enablement when the technologies gets developed and deployed eventually.
So you talked about this is I want to touch upon this a little bit more. So how do you bring about this change? You said the security team has to partner with the development team or the engineering team, and that's what's called DevSecOps. How do you bring about this change? Are there any friction points or any advice for our users in the summit? A lot of people are going through this. I know this firsthand. I know this secondhand. Where it's not easy. I mean, there is a way of doing things, and for good reason it has worked. But people have to change. And so, any advice for these people? How do you try to effect that change in an organization and try to make it work or make it more friendly to cloud native?
There's so much learning from just kind of the years of experience I have gone through that transformation process. We always talk about it from a security standpoint, that security is responsibility of everyone. There's a shared security responsibility. But in order for that to be true, security professional also needs to be an equal partner in the engineering world, meaning that a lot of security professional needs to be more than just security professionals. They need to be the software engineers, they need to be DevOps folks, they need to be infrastructure people, they need to understand the same outcome as everyone else that we're talking to and communicating with on a day-to-day basis. So security professional needs to be as well knowledge around Kubernetes technologies, around service fabric designs, and around public cloud architecture, right? Have to be at the same table talking about solving for the same problem together. So it's not uniquely no longer solving for just the security problem. We have to be able to solve the engineering problem. We have to be able to solve the product design problem. We have to solve the business problem along with the security problem. That way, so everyone becomes an equal partner as part of the process. And that's what forms and drives the long-sustaining relationship that a lot of security team really, really needs to make this successful together collectively in our organization. So a lot of time is about how do we create the right balance between technology enablement and as well as balancing the risks associated with any security issues. So the most important thing is that we need to be able to make sure that we're as involved on the technology side as the technologists are involved on the security side as well.
Right. And I think it's going to be wonderful as this transformation starts to happen. And we should thank Cloud Native or Kubernetes for this. At least it's a big part, because you're going to start to get both these people, the developer who is to worry about how can I write fantastic code to achieve the goals for my application, and then the security person trying to make sure that it's secure code, it's secured, and it follows best practices. They were operating in sort of silos, and now they're merging together. You don't have to. The security starts getting woven into the software from the time it's getting built, and that just makes me think that, in general, you're going to have inherently secure software coming out of these teams, which really helps a lot, right? You start to win the battle very early on, so that's amazing. Shifting gears a little bit, you have, I know for a fact, working with you, you worked to secure a Kubernetes environment before. I'm sure you're doing that in your current role. Any thoughts on, as a practitioner now, what do you think of when you have to secure a Kubernetes environment?
Kubernetes is a really, really fascinating technology, right? I have the opportunity to actually watch it evolve and watch this innovation that happens across industry and how it gained a lot of momentum and a lot of adoptions, right? And it's still easily one of the most exciting technologies that's recently surfaced. But when we look at technologies like this, a lot of times the older principles generally still apply, right? When it comes to one of the most important things, Kubernetes is a container-based technology. So one of the most foundational aspects of things is the application security program. So you have to have a very, very robust application security program to make sure that everything that you're packaging and deploying are actually software. So assuming you have that piece or software in your organization, that could be a very extensive discussion. Then Kubernetes, I start to kind of break it down into the things on how we actually leverage the technology. So a lot of it is around how do you build the containers, how do you actually operate the containers, and ultimately how do you solve for the runtime issues that you would typically encounter. And Kubernetes as a whole is really interesting because depending on your perspective, it could run as an infrastructure as a service, or it could run as potentially as a platform as a service. What that also means is that it's very self-contained. And a lot of the security tools that we are very accustomed to needs to be something that's very aware of the technologies that we're using. So in some ways, having a consistent and agnostic tool is fantastic. But there are times, and I believe Kubernetes is one of these, where a lot of times the security tools need to be much closer to the fabric by which the application context are running in. So Kubernetes is one of these where a lot of tools need to be specialized in the way that it actually bakes into the pipeline, how you actually build and deploy into the environment, and how you actually operate and run the platform itself.
Yeah, can you elaborate on some examples of tools that you would use in this for the cycle? You talk about build, you talk about deploy, you talk about runtime. If you would cover some of the tools that folks need to be looking at to make this work, and you made a great point that they need to be woven into Kubernetes. They cannot be outside. I think that's the point you made, and I agree with that.
So when you're first starting looking at the Kubernetes technology, so let's talk about the packaging, how you build out the containers. One of the most important things is actually, of course, as we already talked about a little bit, is the application security portion of it. And there's a lot of technologies associated with your standard code analysis, dynamic analysis, and software dependency. Assuming that you have part of that solved, then you want to start to figure out how you build up the container. The container needs to practice fundamental principles around least privilege, right? Minimal attack surface around it. So you want to minimize and run the leanest container you can build. So you start with a very, very foundational base container image, and you stack and build on top of it. And there's a lot of great techniques out there in terms of how you layer that on properly. And when you start to build out that container set, that becomes your core execution code. Now you have to start to layer on the capabilities around the Kubernetes and what Kubernetes could bring into the environment around different sets of policy from a security standpoint, from a network policy standpoint. And that's where it starts to get really, really interesting because the security context policies, there's different standards that supports out there. You have to find what that best suits your organization and what you guys are trying to accomplish from a security mission standpoint. And then the network component of it becomes very, very complex very quickly because the Kubernetes as an ecosystem is massive and there's different ways and different technologies to apply on top of it. So you want to layer on and make sure that you're also layering on the defenses. And again, following the similar concepts and principles and make sure that you're doing microsegmentations around the application context as much as possible. You want to make sure that the containers are deployed with a set of policies that minimizes around the privileges that they could execute inside your Kubernetes cluster. As you build through that process, then you want to make sure you have your tools are actually managing the Kubernetes infrastructure in its configurations and the setup, making sure that you understand the technologies that you're deploying and the applications you're deploying on top of it. And ultimately, you get to a state in the runtime, you also want to make sure that there are no rogue instances, there's no rogue configurations, that things stays the way that they're deployed. There's no drift in your execution environment. And that creates another set of tools that you have to worry about in your environment. So ultimately, you want to build securely, you want to make sure that you have a set of infrastructure that evaluates how you're deploying it. And ultimately, you also have to have a lot of observability and capabilities in the runtime so you know what's going on, because in that world, everything is very dynamic, everything is very ephemeral. So you no longer could just do the mapping of the traditional IP to host an application mapping, right? So everything becomes much more complex and much more real time when they're real time at that point on.
Right. So yeah, you covered a lot of things. The excellent analysis, right from build time, deploy time to runtime. Um, uh, you know, uh, let's touch a little bit more upon the runtime. So the last point you made, right, with Kubernetes, your IP is abstracted in a way, right? So it's declarative. So it says, okay, you have these type of pods need to be spun up, and how they network, what IPs they get is controlled and managed by Kubernetes. If something goes wrong, they get respun up with a different IP. So um, in that model, the traditional firewalls that operate on IPs and subnets and networking, they are still very effective at the perimeter. But what kind of roles do you see? How do you, in your view, how do you share control? So there is control inside the cluster, which has to be done the Kubernetes way. Then you have your firewall at the perimeter, which I think you want, frankly, at the perimeter as well, to do your security there. So how do you share control between these? And have you seen? So that's one part of the question. Second part is in the organization dynamics. If have you seen any kind of friction there, or how does it all work, and what is the best way to bring some of those controls or make them coexist?
That's a really, really good question. And it's complex because it does drive a lot of the organizational transformation. It does change a lot of the roles and responsibility that we were kind of referring to earlier, right? In the shift left model, as you're moving into this world, what we don't have is that the security professionals could say, these are the policies that will dictate, and you could actually monitor against that, because a lot of those policies are no longer something that you implement in a different stack. It's part of the Kubernetes environment. What that means is that the administrators, or the typical role of an administrator, now have much more control and power inside the environment. So it does change the dynamics in terms of how security team tends to work with, say, the SRE organizations that's managing a lot of these infrastructures and large deployments. And the trust that needs to be in place is very different. So a lot of times, as we're kind of implying this conversation, is that those security controls now are baked into how things are being deployed. So they're baked into the policies, they're baked into the setup and configurations of Kubernetes in by itself. So security teams now have an ability to actually analyze what gets deployed as it's being done, which is an amazing set of information that we struggle with for a very, very long time, outside before the ages of Kubernetes and changes in the cloud native capabilities. On the other hand, because everything is deployed and managed in code, security professionals have to rely on SREs and the likes of the DevOps tools to enforce those policy sets. So it's absolutely important for security professionals to understand what gets deployed and actually understand it at a code level, as opposed to a review analysis of what happens afterward. And changes in environments are also important too, because you want to be able to have visibility into what's actually executed in the environment to make sure that what you have in code from a design standpoint gets deployed in the same way and gets operating managed in the same way as what you have in the execution and runtime environment. So having that balance of knowing what gets deployed and having visibility of what's actually operating, and having that was going to ultimately give you that assurance from a security perspective that things are working in the way that you design it to operate.
Right. So I think you bring up a good point there. So there's the collaboration aspect, and then the security team that's managing the firewalls today has to collaborate with the SREs or the DevOps, or some DevSecOps people even, to bring those controls or push those controls inside at build and even deploy time. And in Kubernetes, they are essentially labels or selectors saying, these are the set of selectors. Either you do it application based, the role of that, and so on, right? But to me, what's interesting is how these work together, right? So if you think about it, there's obviously the east-west microsegmentation, and if your firewall is at the perimeter, it cannot even see the traffic. So it has to influence one way, saying, and talk the language of Kubernetes to these tools inside the cluster, saying, this is what you will do or you can do and you cannot do. For example, if you want to create zones inside your Kubernetes cluster, it should be easy enough for the firewall to communicate with tools inside your cluster and say, this is a zone, and the zone means these labels, for example, and you could achieve that in many ways. That's one way to do it. There's another aspect of it as well. When traffic is leaving the cluster, you touched upon, you need to have observability. When it's leaving a Kubernetes cluster, typically, because of the way networking is implemented in typical cases, you will not see which the pod level granularity is lost, because inside of a physical host, there is a VM that hosts many containers. Each of them have IPs. By the time traffic goes out, most likely it's natted to the node's IP or has the identity of the node. Now, the firewall only sees the whole node, and you cannot do any kind of restriction for outbound traffic that's leaving the cluster by node, because Kubernetes says, I can spin up any pod on any node at any time and it can change. So again, there is that collaboration where the tools inside the system have to make the firewall or give enough context to the firewall outside. And this is a very interesting area, and there's a lot of innovation going on here. But this has to happen successfully to get this whole ecosystem working. I just want to get your thoughts on this, because we're starting to see that based on talking to people.
Yeah, this is one of the most fascinating things around Kubernetes is actually how the network construct is set up. And to your point, the network overlays that gets built into Kubernetes makes it really, really challenging if we were to look at the traffic that operates outside the cluster. So you definitely have to embed a lot of the security controls that's native to Kubernetes itself. So whether you do it by CNI or you're doing by the different types of network plugins and how you actually manage that, those different technologies. And I know the Tigger and Calico has a great solution behind how you guys operate that. But it is absolutely important. And there's a very powerful statement there, because you're no longer managing network policies, the firewall policies. You're now truly managing dynamic network policies. So based on the workload that you're able to label, you understand what data is being processed or how the transactions being processed, and how you break down your security zones. Now you could translate those to actual network policies that could be deployed dynamically based on what the actual workload is. Okay. And that allows that really ease up the the firewall operational management team, because now everything is tied to those constructs that you build, you implement in code base, and it gets deployed automatically. And that's really what defines and protects what happens within the cluster on the east-west segmentations. But the more challenging part is that you have to understand how those traffics actually egresses out the environment as well. To your point, inside a given Kubernetes cluster, by the time the traffic egresses out, either through natting or through other types of batch that's running in the environment, you might not have clear identity of what the actual traffic origin is when it leaves the cluster if you were to observe the outside. So it's important that you actually understand what those workloads are and understand how you want to control and manage the traffic that egresses out of the cluster, so that you could actually apply the right set of security controls within the cluster itself, as opposed to trying to manage it outside the environment. If you try to manage it outside the environment, by the time the traffic egresses, it's almost a bit of a guesswork to understand what it is. But a lot of times that also kind of depends on how your application architecture is set up and how you overlay your cluster across your entire infrastructure. But it is absolutely an important thing to do to make sure that you understand the workload and what that inter-cluster communication will look like, right? Especially when the traffic leaves outside the environment. But more important thing is, to your point, it has to be embedded inside the Kubernetes control plane. Otherwise, trying to understand that outside environment, it's going to be near impossible. It's going to be a challenge for a lot of the teams trying to manage that.
So Stan, so far, great conversation on, bringing in, the whole shift left concept, bringing in controls. There's a whole area around observability, and, particularly I want to get your thoughts on AI and machine learning in the space of, cloud native security. Do you think they have a role? What are your thoughts on that?
Oh, that's absolutely. I think it's incredible about what the information that we can actually now be able to pick up from observation standpoint, from telemetry standpoint. And the one thing for sure, though, is the fact that the security industry and security professionals just absolutely love getting data, to the point that sometimes it feels like we love data a little too much. And the biggest challenge around that is that what the data we have is two things. How do you collect the data, and what do you do with it? And in the case of Kubernetes and cloud architecture, is that those technology actually enable us to collect data in a way that we have never seen before. The amount of instrumentation you could do to the application workload, to the network traffic, to the current operations and inter-service communication it is absolutely mind-boggling amount of information that we could get. And the more powerful statement behind it is the fact that we could get it in a very, very consistent way that we have not been able to, or they've been very difficult to achieve in the past. And there's different technologies that allows you to now at the cloud native level to instrument down to the code, which makes it even more powerful, right? So now we have this complete observability from the infrastructure network layer down to the operating system kernel system call levels to the application workloads and the intercommunications with the different applications workload that you run in your environment, which creates a second set of problem. So we can finally collect the data that we've all been dreaming of. Now the challenge is how do we parse out what's operating that we would expect and what's anomalous in the environment, right? Then because anomalous behaviors are the ones that are out either from a compliance standpoint that we're interested in, or they may represent a potential malicious attack that's in flight. Is tearing through that rich set of information to understand what is going on in the system. That is the opportunity where we can leverage things like machine learning and artificial intelligence to figure out what are the right set of patterns and what are the outliers, either through communications, through the application system calls. But without that set of technologies in place, it's almost impossible for a security team to figure out what is important and what's not important, because the data we're looking for is just so much more than what we have been able to gather. And we're finally at a place where we are able to actually harvest and collect that data in a very uniform way. So it represents a very unique problem for us.
I'm going to go back first to your topic that it gives you a lot of data. Sometimes we in the security field love too much data or love data too much, which is awesome. But I want to ask you this, and I've always wondered and debated both ways. So, as a security professional, you want the data at the most raw form. What that means in the Kubernetes world, though, is I want IPs and ports and source code and everything, right? Give me the flow as it is. And even today, I hear a lot of people ask for that. Kubernetes, that is challenging. One, because there are many, so it's a distributed system. So what would be a single flow? You have a client server. Now that client server is 5 pods for the client, 10 pods for the server, and they are all talking to each other. So the amount of data is multiplied. So one way to think about it is, Kubernetes is abstracting it, and it's the same code generally, and you can control that through your shift left models. But the same code is running on your 5 pods as the clients and 10 pods as the servers. And Kubernetes is managing pod-to-pod communication. Why not start to look at data as aggregated across those, right? These 5 pods that belong to a deployment, a replica set, or a service are talking to these 5 pods and whatnot. And then you start to view data that way. Are you comfortable as a security professional to abstract it at that level? Because the moment you do it that way, you start to solve the challenge of the amount of data, right? Just want to pause to get your thoughts first on that.
Yeah, I think in the world of how you actually manage workload and manage more traditionally asset management in Kubernetes is a complete game changer, because we need to stop thinking about the workload from an IP-based standpoint. We need to start thinking about it from workload and from a service standpoint. So at that point, most of the time we're cross-referencing an IP address to some host name to what's actually running on top of applications. But if you set up Kubernetes in the right way and you have the right structure in place and you trust what's deployed out there, and there's very, very good ways of actually getting that level of trust in the system, at that point, then it simplifies what we're looking for. Now we could truly look at the application communications. Is it from application A talking to application B? If you could trust that communication, then you understand what's going on within the environment, then you have a much higher degree of confidence in terms of understanding what's happening there and what does normal operation looks like versus what potentially anomalous behavior looks like. Would it be a malbehaving application or something a little bit more malicious than that? So it does simplify that discovery process, that detection process for a lot of secure professional. And a lot of it starts with what we've been talking about earlier. So you have to shift left. You have to be able to build the trust in the tools in the way that you're managing Kubernetes. Then the data that comes out of it could potentially be much easier to understand what that means. So
Yeah.
absolutely, there's a very different world in that space.
Yeah, spot on. I think that's exactly how I think about it, because once you abstract it to that level and build trust that this is application to application, now you can start to look at an anomalous application as opposed to looking at an anomalous pod. Completely different problems, because even machine learning algorithms will get confused because they work, especially the ones that work on clustering. If there are 5 pods of the same type and they're trying to do the same thing, it's better sometimes you're aggregating them and starting to say this group of pods, namely an application, is behaving differently from that group of pods, and then you can break it down further. It starts to become very, very interesting. So start to get into that field called entity behavioral analytics. The entity here being an application, which is a group of pods, starts to take shape as a good building block as innovations come in. Let me ask you this: have you seen what more innovation in the field of AI and ML? It's always been a little bit questionable and slow to start, if you will, where you see an AI application in cybersecurity. A lot of them are starting to come, though. Want to get your thoughts on that?
There's a lot of really great data analytics company, and it seems like they're popping up on a monthly basis too, right? I think there's a lot of innovation, there's a lot of opportunity in that world. I think some of the things that we're talking about today becomes extremely important, because a lot of what we're able to do now is actually shift away from data enrichment around what we've been talking about around IP mapping to workloads. Now, if you could actually start to apply labels where the systems can actually learn and understand what's going on, then this is where the power of natural language processing, because now the events are something that we humans can understand, machine can understand much easier. And that's when we actually start to understand statistically how things are operating. We start to identify outliers. We start to identify clustering of communications, where it should be very, very predictable when everything works well. So that allows us to really to pinpoint on those situations where things are not. The biggest problem there is, of course, the amount of data that we're able to collect now, right? So it's important for us to actually have strong practices in data pipelining in place, so we can actually have the right set of data going in. So you extract out the right sets of data features to build the data model behind. And there's a lot of really fantastic tools, and there's a lot of very rapidly evolving mechanisms and algorithms that we can actually start to play with. But a lot of it is really understanding the environment. How do we bake that in so that we have confidence in the data that we're actually collecting out of the environment to actually start to model that out. And I think for a lot of organizations, if you're early in the journey, if you're something that you just started to do, it's something that you want to start with simple and you want to build out the capabilities over. And what you'll probably end up finding is that there's not a single algorithm that you're going to end up using. It's going to be an aggregate of multiple algorithms you're using to find different things. At the end of the day, you have to look at the data that you get back from each one of those data models to build a true risk model to understand what does normal look like, and ultimately allows you to find those that are not.
Awesome. Yeah, I agree with you. I see a lot of innovation in this area, and it's really exciting to see that coming into cybersecurity. Now, one last thing that I wanted to cover was, if someone is in the process of migrating to a Kubernetes-based architecture, and I know you know this firsthand, so can you share your thoughts, your knowledge, and to guide someone who's considering migrating to a Kubernetes-based architecture from, let's call it a traditional architecture for the way they do their applications?
Yeah, I think one of the themes from our conversation that I'm picking up is really we need to think about the problem more holistically end to end. We can't slice out just the particular infrastructure application layer in a lot of the common ways that a lot of us actually break down the problem into. We have to look at it from end to end. So you need to plan accordingly. You need to build the partnerships early on. You need to make sure you have the right organizational structure in place. Because the Kubernetes ecosystem is really rapidly evolving and maturing. So there's a lot of challenges that you have to continue to stay up to speed on. And you have to be able to rely on the underlying foundations you have in the organizations and tools you have in place. And that will start to help you solve for different size of scale problems and different types of problems you'll probably run into. And you continue to learn from those experimentations that you will run into on a day-to-day basis. And then from there, it's just be flexible, be portable with the technologies, partner with strong providers that have a long history of actually solving for these complex problems, and make sure that you have an ability to actually deliver a solution that you will need in the future. So one of the biggest challenges is actually understanding what you need now, but also understanding what you need in the future, and having that partnership with different providers will help make sure that everyone's successful in their journey.
Thank you so much for your time, Stan. I think this will be very valuable to our users. I really appreciate you taking the time. I enjoyed my conversation with you.
Likewise, Manish, it's always a pleasure to speak with you and an opportunity to just connect with the industry as a whole.
Thank you.